Hello friends, how are you? Today we are going to study a very important theorem, that is Chinese remainder theorem. Okay, so friends, I will try to explain this theorem in very simple way. So let us start. This theorem states that let m1, m2, m3 and so on up to mn are positive integers and GCD of mi and mj is equals to 1 where I is not equal to j. Friends, what this means? This means that among these integers GCD of every two integers is 1. Okay, so these are relatively prime. Okay, if you get any two of these integers and find GCD, that will become 1. Okay, then x is congruent to a1 modulo m1, x is congruent to a2 modulo m2 and so on up to x is congruent to an modulo mn. Has this is given as equation number 1. Okay, has unique solution with respect to modulo m. And what is m? M is product of m1, m2, m3 and so on up to mn. Okay, this system of equations has exist only one solution, and the solution which is given name as x bar, and the solution is given by x bar is equals to a1 m1 m1 inverse mod m1, okay, plus a2 m2 m2 inverse, this is taken over mod m2, plus an mn inverse mod mn, and this whole terms is taken over mod m. And what is m? M is product of m1 m2 m3 dot up to mn. Okay, and what is mi? M upon small mi, that is if we want to find m1, that is capital M upon small m1. If we want to find m2, then what is m2? M upon m2. Similarly, m3, mn can be find this way. Okay, so now let us see example. Let us see an example to explain this theorem. Okay, so we write here system of equations x is congruent to 1 modulo 3, x is congruent to 2 modulo 4, x is congruent to 1 modulo 5, sorry 3 modulo 5. Okay, x is congruent to 1 modulo 3, x is congruent to 2 modulo 4, x is congruent to 3 modulo 5. So we give overall this equation number 1, and here if we compare this system of equations to the general equation of systems, then we get what is here a1 is equals to 1, a2 is equals to 2, a3 is equals to 3. Okay, what is small m1? That is 3, m2 is 4, m3 is 5. Okay, now we calculate capital M. What is capital M? Capital M is product of m1, m2, m3, m1, m2, m3, that is 3 into 4 into 5, that is 60. Okay, what is capital M1? What is capital M1? That is capital M upon small m1, that is 60 upon 3, that is 20. Okay, what is m2? What is m2? M upon m2, that is 60 upon 4, that is 15. What is m3? What is m3? Capital M upon m3, that is 60 upon 5, that is 12. Okay, so now the solution is A1, M1, M1 inverse, and so on up to last term. Now we put all these values in this equation. Okay, what we get? So let's move further. Now, what is A1? A1 is 1. What is M1? M1 is 20. What is M1 inverse? That is 20 inverse, and this term is taken over mod M1. Mod M1. What is M1? M1 is 3 plus A2. What is A2? A2 is equals to 2. What is M2? M2 is equals to 15. Okay, M2 is equals to 15, and this 15 inverse, this term is taken over mod 4. M2 is 4. Okay, plus A3. What is A3? A3 is 3. Okay, M3. What is M3? M3 is 12. 12 into 12 inverse mod 5, and this whole term is taken over mod capital M. What is capital M? That is 60. Okay friends, so now solve these terms. 21 to 20, and what is 20 inverse in mod 3? So first we find what is 20 mod 3. Okay, so divide 20 by 3 and get remainder 3 6 18, and we get remainder 2. That is 20 inverse can be written as 2 inverse, because 20 is congruent to 2 modulo 3. Okay, so modulo 3 plus 2 15 30. What is 15 inverse? 15 inverse modulo 4. First we find 15 modulo 4. What is 15 modulo 4? Divide 15 by 4 and get remainder. So 4 3 is a 12, and remainder is 3. Okay, so 15 inverse can be written as 3 inverse in modulo 4. 12 3 is a 36. What is 12 inverse modulo 5? First we find what is 12 modulo 5. Divide 12 by 5 and get remainder, that is 2. So 12 inverse can be written as 2 inverse modulo 5, and whole term is taken over modulo 60. Okay friends, so I erase this portions. Now how we can find 2 inverse in modulo 3? Okay, so for this, what is 2 inverse? 2 inverse, that is 1 by 2. Okay, now since we have to calculate this 2 inverse in modulo 3, okay, listen carefully friends, we have to calculate 2 inverse in modulo 3. Therefore we add here some multiples of 3 such that this whole terms can be divisible by 2. Okay, since we have to calculate 2 inverse in what? In modulo 3. In modulo 3, therefore 2 inverse can be written as 1 by 2, and in numerator we have to add some multiples of 3, that is 3 1 3. Either you add 6, either you add 9, or you add 12, 15, 18, such that these whole terms can be divisible by 2. Okay, so let's move. Suppose we have we take here 3 1 ja 3, that is 3 1 ja 3, 3 plus 1, that is 4, and 4 can be divisible by 2. Then what get answer? That is 4 by 2, that is 2 2 ja 4. So 2 inverse is congruent to 2, can be written as 2. Therefore 20, and what is 2 inverse? 2 inverse is equals to 2. Okay, plus 30 into 3 inverse. Now how can we find 3 inverse in modulo 4? 3 inverse, that is 1 by 3, we have to find over modulo 4. So add in numerator some multiples of 4, either 4 1 ja 4, or 4 2 ja 8, or 12, or 16, such that these whole terms can be divisible by 3. Okay, so if we add 4 1 ja 4, 4 plus 1 5, 5 is not divisible by 3. 4 2 ja 8, 8 plus 1 9, and 9 is divisible by 3. So we add here 8. Okay, so 8 plus 1 9, 9 divided by 3, that is 3. So 3 inverse can be written as 3. Okay, so 30 into 3 plus, next is 36 and 2 inverse. What is 2 inverse in modulo 5? So 1 by 2, 1 by 2, add some multiple of 5 such that these whole terms can be divisible by 2. That is 5 1 ja 5, 5 plus 1 6, 6 by 2, that is 3. That is 2 inverse can be written as 3, and these whole terms is taken over mod 60. Okay friends, so 20 to the 40, 90, and this is 108 mod 60. Now 130 and 108, that is 238 mod 60. Okay, 130 108 238. Now 238, that is 238 in modulo 60, what will become it? That is 6 3s are 60, divides 238, then what is remainder? 3 is a 180, and that is 58. Okay, so this is congruent to 58 modulo 60, and this is your answer. X bar is equals to 58 modulo 60. Okay, so friends, this is the solution of the given system of equations. I hope that this will explain to you very well. If any doubt is creating your mind, then please ask, and if you like this video, then please like the video and subscribe the channel, and subscribe my own channel whose link is given in description box. Thank you very much. Jai Shri Krishna.